Hi, welcome to today's lesson. This is Wapfu TV. If this is your first time watching us, do well to subscribe so that you have all our videos. Today we are looking at something new, that is prime numbers. We've mentioned prime numbers in most of our lessons, and today we want to really treat it in details to know what exactly prime numbers are. What are our objectives for today's lesson? First, we want to be able to list prime numbers up to 100. Secondly, we want to be able to identify composite numbers. And thirdly, we want to be able to identify prime factors of numbers. These are the targets that we want to achieve by the end of our lesson. Let's take note of something before we proceed. What is a prime number? A prime number is a number that has only two factors. I repeat, a prime number is a number that has only two factors. And what are these two factors? 1 and the number itself. So if you are calculating the factors of a number and you find a number that has 1 as its factor and the number itself, these are prime numbers. We are going to do that in details using our beautiful table that's already prepared to find or identify all the prime numbers between 1 and 100. Now let's move to the next thing, which is composite numbers. What are composite numbers? As we've mentioned in our objectives that we want to identify or to be able to define what composite numbers are. These are numbers with more than two factors. E.g., we have 4, 9, and so many of them. But for now, at the elementary level, just take note that composite numbers are numbers with more than two factors. So these are numbers other than prime numbers and 1. What are prime factors? These are factors of a number that are prime numbers. For instance, if they ask you list prime factors of 15, first you identify the factors of 15, which are 1, 3, 5, and 15. They are simply asking you from these factors, which of these factors are prime numbers? And they are 3 and 5, because 3 has only two factors, 1 and 3, and 5 has only two factors, 1 and 5. That's why they are prime factors of 15. That said, how do we now identify the prime numbers between 1 and 100? The rules are simple. We are going to state it and we follow to eliminate the numbers that are not necessary as far as prime numbers are concerned. And at the end of it all, we are going to have a list of prime numbers between 1 and 100. Take note, prime numbers are just as important as the name suggests, because we use most of these prime numbers to calculate, and we'll use it subsequently in our topics to come, like in fractions and so many others. Okay, we are going to go straight into how to identify prime numbers, and we want to limit ourselves to up to 100. These are the rules to follow. First, we have to come out with a table which is already prepared, as you can see on the board. A square table numbering up to 100, that is 10 by 10. Once this is done and the numbers are outlined, the first rule states that cross out 1 since it is not a prime number. 1 is not a prime number. So as the rule states, we have to cross out 1. Let's just put a line or a bar over it. The next rule states that we should cross all the multiples of 2 except 2. Cross out. So we're going to go to our table and we'll cross out all the multiples of 2, leaving out 2. 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60. All the multiples of 2 except 2 have been crossed out. Next rule states cross all the multiples of 3 except 3. Cross out all multiples of 3 except 3. We're going to do a similar exercise as we've done with 2. 3 will not be touched. So the next is 6 is crossed already, 9, 12 already done, 15, 18 already done, 21, 24 already done, 27, 30 already done, 33, 36 already done, 39, 42 already done, 45, 48 already done, 51, 54 done, 57, 60 done, 63, 66 done, 69, 72 done, 75, 78 done, 81, 84 done, 87, 90 done, 93, 96 done, 99, we cross it. So for 3, all the multiples of 3 except 3 have been crossed out. The next rule is cross out all the multiples of 5 except 5. Cross out all multiples of 5 except 5. We go back to our table and cross all the multiples of 5 except 5 itself. So 5, we leave it. We go to the next, which is 10. 10 is already done. 10, 15, 20, 25, 30, 35, 40, 45, 50 done. 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100, which is already done. We've crossed out all the multiples of 5, leaving out 5. Let's go to the last but not the least, which will enable us to come out with our list. Cross all the multiples of 7 except 7. Cross out all multiples of 7 except 7. Let's go back to our table. We first of all identify 7. We don't touch it. We go to the next, which is 14. 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 91, 98, already done. We finish up with the multiples of 7, leaving out 7. Once this is all done, then we can identify the rest of the numbers which have not been crossed out as the prime numbers between 1 and 100. Therefore, prime numbers equal to, starting with the smallest there, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and finally 97. These are prime numbers between 1 and 100. Take note, because these numbers, most of the time, you will see them coming up when we go to other topics and lessons in elementary mathematics. With this said and done, I believe you learned something. And if you did, click the subscription button, hit the notification bell, share and like our videos, comment so that we can improve the service, and see you in our next lesson. We will be talking about index notation. Don't miss it. Ciao.